Thank you, everyone, for being here. So we have a story to tell and some announcements. So thanks for having you all here. So what we do at Nanoprecise is we are envisioning a world where machines like pumps, compressors, turbines, anything that rotates can tell us what maintenance is needed and when, so as to drive efficiency and prevent unplanned downtime. So why is that important? What we looked at and was very interesting is more than 60% of the global electricity consumption is due to rotating machinery. Like I said, pumps, compressors, turbines, etc. And as you can see that graph, it's very clear that compressors, gas turbines, pumps, power generation systems, those rotating equipments are the ones that are failing more often, right? So naturally, they need maintenance more often than other machines. Now, when we look at, everybody talks about there are $1 trillion in global downtime losses. Interesting thing to note is more than 70% of this $1 trillion in global downtime losses is caused due to rotating machinery. So it is important to understand where to concentrate first to gain those quick wins. As we say, spend 20% of the effort to solve the 80% of the problem. That's what it is about. And when we look at the total life cycle cost of a rotating machinery, we find that power consumption is over 70% of the cost of the machinery, right? Maintenance is important, and then later on, if the machine goes to downtime, production losses are important. But what if we can take care of the maintenance? What if we have a system that can prescribe a right maintenance on a right equipment at right time so that you can save the power and eventually also save the downtime, a best of both worlds? So that's what we are talking about, what we call as energy-centered maintenance. Our energy-centered maintenance solution is a SOC 2 Type 2 cybersecurity approved, certified, or compliant solution. So it's a 5-step process. Number one is, so we use IoT-based sensor and AI-powered software. So the first step is we do edge-based anomaly detection, which is basically 1 day or 2 day, anomaly detection based on a 1 or 2 days data, right? Very short-term anomaly detection. And then we also do anomaly detection on the cloud, which is much longer, time period data anomaly detection. So that's just one part. That's just step one, because anomaly detection only tells you what's weird in the data. It does not necessarily mean something good or something bad. It just means something weird. So the next step is, what does that weirdness alludes to? So that's where we do the next step, which is called automated fault diagnosis. Which component inside the machine has a fault? And that's where we use Pattern Finder, which I will talk about, which we just released in the market, and I will talk about in the next slides. Using that, we are able to determine the faults for which we have the machine data and also for which we don't have the machine data. That's the power of LLMs. That's the power of generative AI, apart from the traditional AI. And we are very excited about that. It's very powerful. The third step, we found the fault. But as you know, the machine is as good as its weakest link. So what's the remaining time to failure of the machine due to that fault mode? So that's what we do, more different kinds of AI, like Weibull distribution, Gumbel distribution, and all of that. But this is good to tell a user that he has some maintenance to do. But how to incentivize the behavior? Because we all know change management is the most difficult part. And what we learned is that the best way to affect a change in the human behavior towards maintenance is to show actual benefit in terms of the dollar values, what he's losing right now, not 5 months later. And that's where the fourth step comes into picture, which is because from a simple law of conservation of energy, if there is a fault in the machinery, 100% it is costing you more in energy right now. So what's that increase in energy consumption due to a bearing fault or a shaft fault or a seal fault, something like that. So we also calculate that in terms of the kilowatt hour, in terms of the carbon emissions, or in terms of the dollar value. In fact, to make it more appealing, we are also showing that how many homes in US if you do the maintenance right now, how many homes in US it will power because of the energy saved. It is directly causing that ripple effect in terms of doing that maintenance, proactive maintenance. And then the fifth step, all this is good, but what's the root cause? Because a fault is just a symptom, just like cancer is just a symptom. What's the root cause which is causing that cancer in the first place, or a bearing fault in the first place? And what's the associated maintenance action? Because your maintenance action is dependent on your understanding your root cause. So that's what is our overall energy-centered maintenance. And we use, as you see, we happen to have our own sensor, because we looked at all the kinds of process data in the industry, and we figured out that process data alone is not sufficient, because you need to measure how the system is responding to those process conditions. So process parameters will be like pressure, temperature, flow rate, while the system response parameters will be things like vibration, sound, magnetic flux. So it is important to measure those system response parameters to be able to do energy-centered maintenance in a full scope. And then, of course, process parameters are important to understand the context behind it, so as to pinpoint what is the root cause and associated action. So with that, I want to announce that we have just been able to finalize a funding commitment of up to $25 million. And we will be able to release the names of the parties very soon, probably by the end of this month. And so we are happy to announce that these are really sophisticated investors and who can fund us for a long time in our journey of revolutionizing the world with energy-centered maintenance. And we also have now increased line of credit and some R&D grants. So all of this will be used, the equity will be used for the growth to spread energy-centric maintenance to the customers worldwide, while the debt will be used for CapEx purchases for the sensors, and then the R&D grants will be used to spread our agentic AI. So let's talk about our second announcement. So we are very, very proud to announce our advanced machine doctor web analyst agent, which is basically bringing large language models and generative AI. So with this, what we can do now is basically, as you can see, we can basically determine the patterns without even the machine information. Of course, machine information will help to pinpoint basically what is the fault mode, but even without that, we can at least tell that this pattern is very specific to a specific fault mode, and having that machine information will further determine exactly what is that. But even without that, we can, with whatever data we have seen, we already have detected almost 90% of the problems that are existing. So we can learn from that. And as you can see, the moment as you see that graph, like the pattern automatically started rising. So this is really powerful because it really doesn't matter whichever industry you have, whichever machine you have, as long as it's a rotating machinery, because in a rotating machinery, everything is mounted on a shaft. With the agentic AI, we are able to determine the problem. It's really powerful. Now, what is our agentic AI? So with the pattern finder, we can tell what are the fault modes, but by using the reasoning agent, basically, we are able to tell what's the context behind that fault, means what's the root cause behind that fault. So reasoning agent reasons, takes the process data, machine logs, machine maintenance logs, and correlates that with any kind of our own data, our own analytics that comes from the pattern finder, and then tells you what's the specific maintenance action required, right? What's the root cause and what's the specific maintenance action required? So this goes a long way in automating work orders and basically helping customers focus on the maintenance rather than worrying about any more analysis, right? So this pattern finder has improved our accuracy from what we were doing maybe 6 months back by almost 50 to 70%. It's a massive improvement. Even before we were pretty accurate, but now we don't even need, without even the need for equipment information, because a lot of our customers have very old plants where the machines don't have any info. Even without that, just with a signature of vibration and sound and running those LLMs, we are able to recognize between what is the actual fault-related pattern versus what is the normal, process, operational fluctuation-related pattern. It's really powerful in basically reducing the false positive without the need for customer data. Thank you.
Okay, questions for Sunil? Who has a question?
I was just curious, seeing your, the search function run. Is it all similar to, how internet searches are done? Is it similar? Because the internet, when you do a query on Google or something, it searches through voluminous information. Is this similar to that? I'm untutored, so.
It is a little bit similar to that, but not on internet data, but
Right.
on the data that we have collected so far.
No, but I mean the mechanics of the search, how the search is conducted. Is it function in a similar way?
Yes, and I would say we are using large language models, and with number of hyperparameters, and so what the advantage that it is giving now compared to what we were doing in the past is we are able to simulate data ourselves. So that's what is artificial generative intelligence, is that it is automatically, if we set the thresholds, it is automatically able to create number of other use cases for which we don't even have data. So basically, it is automatically thinking beyond what we have data. So that's really powerful. That's the difference. In the past, we were only training on the data we had, but now we are creating our own data based on whatever we have and the thresholds. Yeah.
Another question?
Hi, Sunil. So the distinguishing thing from other asset management programs that somebody might have in their company is the energy saving. So if you have a customer, can they have an audit trail or a record of how much electricity was saved by, do you have reporting tools?
Yes, absolutely. So I can give you 2 case studies. So for one of the water utility, we determined that there was a pump cavitation issue because of a increase in the vibration frequency at the pump impeller frequency, and we anticipated the energy consumption to increase by around 15%. And we told the customer, they took an energy meter and they basically first took off the pump, shaved off some material on the pump impeller because it was not symmetrical. So after that, they again installed, and the cavitation went away, and the energy consumption came down by 20%, right? So just imagine it was running with that fault for 2 years. So it's not like if you have a fault, it will necessarily fail right away. Sometimes you can run with a fault in the machinery for a long time and still costing you way more in power consumption than the cost of the pump itself. As you can see, this graph, the cost of the pump doesn't matter. It's only 2 or 3% or max 5% of the overall life cycle cost of the operating that machinery. It's running that machinery with a fault which really costs. So in that way, what we are seeing in the buildings, we can easily save anywhere from 10 to 15%, because in the buildings, in the HVAC, in this building, in the HVAC, all the power consumption is due to the rotating machineries like air handler units, chillers, compressors, all of that. Any improvement by doing the timely maintenance of that goes a long way. So 10 to 15% is easily we can save there. And even in industrial facilities like any manufacturing, we are anticipating anywhere from 3 to 5% of the total annual energy consumption can be saved just by doing the right maintenance on a right equipment at the right time, specifically on rotating machinery. Yeah.
Any other questions? Lucia?
Thank you, Sunil. So maybe a dual question. First off, who's your target user for machine doc viv analysis? And then secondly, can it help us set the KPIs for it? For instance, I'd like to be able to explore opportunity to save 15% of energy.
Yes, so to answer your first question, mostly our users are, basically any kind of manufacturing or any kind of buildings like airport, wherever basically the energy consumption by rotating equipments is more than 40% of your total energy consumption in that particular facility, right? That is a critical threshold point. And another threshold point is where more than 50% of your downtime is caused due to rotating machinery. That's another critical point. And then answering the second point regarding KPIs, so one of the KPIs that we measure is false positive and false negative. So we see that less than 1% false negative is a given. If you have more than 1% false negative, that breaks the trust. So it's very important to keep that as a number one criteria. Number second criteria is false positives, because false negative is definitely that breaks the trust right away. So that is like uncompromisable. But even false positive is important, because if you have a lot of false positives just to reduce false negatives, then what happens is ultimately it builds that behavior within the users that, oh, they're sending a lot of notifications, so I'm just going to ignore it. So reducing false positives is also important. So we consider less than 5% false positive as key, but over time it should even reduce to less than 1%, even false positive, right? And with agentic AI and the pattern finder that we are getting to, now we are very confident that less than 1% or less than 2% false positive is totally possible, thanks to generative AI. Yeah.
What are you training your machine doctor on? So where's the data coming from? How much is kind of out of the box, and how much fine-tuning does a client have to do?
Yes. So we have around 20,000 sensors installed. And the good thing with us is that we have been very diverse in terms of the industries we have installed. Like, we have installed in oil and gas, mining and metals, and, steel, cement, pharma, automotive, HVAC. So we have, and the best part is like 35% of our business comes from US, 15% comes from Canada, 20% comes from India, and then rest comes from Middle East, Asia, and Europe. So you can imagine we have the data of different industries. We have the data of different geographies, means different conditions. So that gives us good enough base, and now you can create or simulate data based on this by setting the limits. So this is the bearing threshold value. How many different ways, how many different permutation combinations it can take to reach that route. So that is where we are creating data. So from just 20,000 sensors of data, we can actually create probably 1 million sensors kind of data, because we have the data from different industry and from different geographies, which is basically characteristic of the overall world data. So that's what we see very powerful with this, like new agentic AI approach that we are taking. Yeah.
Yeah, Mark, please wait for the mic. Thank you.
Why is this better than other predictive maintenance products on the market?
I would say right now, we are one of the early ones to take that kind of chat GPT approach to predictive maintenance, right? So eventually, I mean, like everybody would do that, but at least we are the one of the early ones to enter into it. So that's, I would see this as a way of, chat GPT for predictive maintenance for, and just like ChatGPT got its own, competitors we might have. The good part about us is, even though we call it as ChatGPT for predictive maintenance, but our approach has always been like a deep seek. We have been frugally, we have incorporated the frugal engineering principles. That's why we do, fair bit of AI on our sensor edge. Just imagine, we are doing some AI on an 8 MB RAM on our sensor. So that's powerful, because that is not easy. I mean, doing it on cloud, taking hundreds of thousands of dollars in cloud computing, that will have some, some kind of a limit. But here we are doing, instead of sending the whole haystack to the cloud, we are doing a lot of analysis at the sensor edge itself and only sending a needle from the haystack, and further actually doing AI on that. So that's what I would say is very different, that the combination of edge plus cloud and that kind of a DeepSeek inspired frugal engineering to keep the costs low and not make it very expensive for the customer just because it is generative AI. Yeah.
And security?
Yeah, so we are that's a great question. So basically, as you saw here, so we just got our SOC 2 Type 2 compliance. And I mean, we have been SOC 2 Type 2 compliant for the last 2-3 years. But as you know, you need to renew that compliance every year. So we just got it again. So we are very, very, careful about the cybersecurity, both in terms of our sensor edge and even on the cloud, and like have all the, protocols and procedures in place to ensure that there is no step that is missed and so that we are compliant all the time. Yeah.
This is the last question.
Okay, thank you. It's kind of a follow-up to this. In looking what you had presented on the screen, you had what looked like a language model or a series of information coming across the screen, but it wasn't data points.
Yes.
So I realize that you're looking at sensor output, so it could be vibration, it could be voltage, it could be whatever, correct? And then are you also looking at logs or comments from operators? What was the language piece of it, I guess, is what I'm
Yes.
driving at.
So that comes under this reasoning agent, and absolutely right. Like, we are also looking at the feedback of the maintenance technicians and real time. So that's why what we make sure that they're not putting some random feedback, but we have identified some, let's say, 4,000 types of feedbacks that are very common, and we only let them select. Instead of them selecting from those 4,000, we decrease that pop down to based on a certain things, maybe 3 or 4, so they can select from that. So based on that, we are able to, create more and more, simulate more and more data, and make it even more intelligent over time. Yeah.
Maybe one last probing point to that. Like, so if in your example, I think it was an impeller you said in a pump, how did they know to go in there that the impeller was out of balance? Was that something that they had noted in a past example that they could reference, and then the model would say, hey, this happened before, check that? Or did the maintenance team just realize that? Or how did
Yeah, that's a great point, because in this example that I mentioned, the pump impeller, we didn't even have the number of vanes on the pump impeller information. Despite of that, we saw some increase, and then one of the site guy, who was a certified vibration analyst, he actually calculated and figured out, oh, this is happening at the pump vane. So then he opened it and then took it off the service, because that was not a very critical machine, production critical machinery, and they had a backup in place. So they took it off and they saw that there is some construction damage. That means they had that problem since the inception, for the last 2 years when they installed that pump. they have been losing almost 250 horsepower pump. They have been losing $45,000 in electricity just on that pump in 2 years, right? So that's and they shaved it off, made it more symmetrical, and immediately 20% decrease in energy consumption.
Okay, thank you very much, Sunil, for your presentation. Appreciate it.
Thank you.